Today, again, yesterday we studied about the right angle triangle. Quick recall of the right angle triangle. Two rules are applicable on the right angle triangle. Yes. First of all, the side opposite to the right angle is called the hypotenuse. If this is the angle, the side opposite to the angle that you are considering is the opposite, and the side with the angle is the adjacent. And Pythagoras theorem, the equation of the Pythagoras theorem is hypotenuse will be equal to square root of opposite square plus adjacent square. And adjacent is hypotenuse square minus adjacent square. And the opposite is hypotenuse square minus, no, sorry, here it will be opposite, okay? And if it is opposite, so adjacent square you subtract. And then it is su ka and twa. Su is for sine. Sine is always equal to opposite over hypotenuse. And cos cosine is equal to adjacent over hypotenuse. And twa is equal to tangent. It is equal to the opposite over adjacent. Yes. So sine, cosine, and tangent, these are in right angle triangle. You don't need to think about anything other than these. Okay. Now, yesterday, obviously, I took some questions that were the basic question where you learn how to use the SOHCAHTOA, sine, cosine, and tangent, all this stuff. So today, inshallah, we are going to start the Pythagoras theorem, the question related to the Pythagoras theorem, okay? And SOHCAHTOA combined questions we will take. So at least right angle triangle, usage of the right angle triangle, you will understand, okay? Before I start, anybody can say when we will use the Pythagoras theorem? When we need the third side in the right angle triangle having the fact that we are having one of the sides. Yes. Okay, that's good. And SOHCAHTOA we can use side, not every triangle, right angle triangle. Okay. Let's say, for example, I'm having a question here. I will take it as an example. This one is, then calculate the length of AB. Like this side AB, you have to find, you are having the other two sides. So Pythagoras theorem will be applicable on that. Why? Because it's first of all right angle triangle. Yes, it's a right angle triangle. Being the right angle triangle, this one is the hypotenuse. This one is the, look, now you are not restricted with the angle. Yes. So it's your choice. You consider this angle or this. I'm gonna consider this. So this is going to be the opposite. This is going to be the adjacent. At the end, it will not affect it when you find. Okay. So it means if you have to find the AB, so the formula is hypotenuse. Mean AB will be equal to square root of the opposite square, mean AC square, plus adjacent square, which is BC square. So you can say it will be AC is 14, so 14 square, plus BC is 9, so 9 square. So let's calculate this one. So it will be, I'm having, I don't know on this calculator I have or not. I'm trying to add that calculator in the within the application so it become easy to use. But anyhow, can anybody calculate this, please? Because I don't think so. I have a basic calculator I'm having here. So let me update that. Need to so calculate it just 14 square plus 9 square square root. Directly on the calculator you have to calculate this one. Understood or not? That's pretty simple. Without any difficulty, you guys can do that. Okay. 16.64. So as you have to find the answer to one decimal place, so you should show two decimal places and then round to one. So that will be 16.6 because if you will leave it, it will not affect it. Centimeter. Okay. Now next question that I'm going to take, it is slightly technical, but again, you should remember the rules that we already know. Look at this question. It is actually a trapezium where these things are given, but it is given that this angle is 90 degree, this angle is 90 degree. Calculate the length of AC. What is AC? This is AC. You make AC here. So it means if you have to find AC, so you will use this right angle triangle because this will be ABC is a right angle triangle. Yes, a right triangle. So for finding AC, it means if you draw it separately, just ABC. So this is obviously this is A, this is B, this is C, and this one is we know AD, we know AB, but the BC is not there. And calculate the length of AC to three significant figure. There is a problem in that. A small problem is there actually. Uh, Sukatwa, but I know need one of the angle. That's the problem. The problem is that if there is any additional information in that one, I can do because sine and cosine rule are there for non-right angle triangle. Using this one, I can come to that. But it's missing there. I'm not having this one. So in that situation, if it is, I need to because remember in right angle triangle I told you you need three things. Then other three you can find. But in this one, if I take this is 9, just I have just two things. Third thing is not there with me in this right angle triangle. DC is there, hmm, but there is a problem with that also. So you know what I will do? I have another solution here. No, there is no way given it is 45 degree. Okay. So for such situation, I will use my common sense. From here, if I take it, look here. If I will take it from here, hmm, what this would be? This would be a right angle triangle as well. Because easy question yesterday we did. Obviously, we have to move towards something. This will also be 90 degree. Because if this is 90 and I draw a parallel line, this will also be 90. So I will consider this triangle. Okay. In this triangle, I will find this one because I'm having this 10. Okay. And till this one, look, it is 3. So it means this is also 3. Yes. If this is 3, so what is this remaining one? 6. I mean, this is 6. Yes. Okay. This is A. You can call it E. Give it any name. E. This point you can call as E. Now I have three things. Yes. 2. So I can easily find the third side. I can find or not. Using the Pythagoras theorem. Yes. This one is the hypotenuse. This one you can say, if you consider this, for example. Hmm? If you consider this one, you can say this one is the opposite or adjacent. That will not affect you. Use this, that doesn't matter. And this one opposite. You have this, you need to find this. So Pythagoras theorem, yes. So what will be the adjacent? Adjacent is equal to square root of the hypotenuse square minus opposite square because you have opposites. So adjacent is ED. It will be, what is the hypotenuse? 10 square minus, this is 6 square. So 64 square root 100 minus 36, 64, so 8. It means this is 8, yes? If this is 8, so this will also be 8 because it will be a rectangle and rectangle opposite sides are equal. So this is 8. It means this is 8. And you have to show all that working. Okay? This is 8. So now you have look 1, 2, and the third thing. You can easily find, as you need to find AC, so AC is the hypotenuse of this one, yes? This one you can say is adjacent, this one is the opposite. Even if you call this opposite this adjacent, it will not affect it at all because no angle specification is there. If no angle specification is there, so obviously there is no issue in doing that. Okay, so go with that. I think now what will be AC? Hypotenuse will be equal to adjacent square, mean this plus opposite square. So that will be 64 plus 81 is going to be 145 square root, and you can calculate that. What will be the answer to this one? Anyone if having the calculator, calculate. Understood or not? So it is not always that you will get the uh, ready stuff. Sometimes you have to gather the raw material. The raw material is always within the question, but you need to work on it slightly so you will be able to get it. Okay. Yes, guys. Clear or not? Even if you have to find this angle, can we find that step by step we are going to do? Okay. Hmm? There is like a deep silence, no reply whether understood or not. Hmm? Yes, Ishal, and then okay, open your brain here right now. Till now, you know only right triangle, and this should be always your preference. Search out the right triangle, okay? All that data is given, you have to find DP. Where is DP? This is DP. Check, is there any triangle that can help you to find DP? Hmm? If you take this triangle, which is DPA, no, never. If you follow the procedure I said to you, it will be the easiest thing. This is DPA. Now, look at that. Maybe it will fail. This is the first time in my life I am looking at this question, believe me. So I will plan it and I will tell you. And I deliberately choose a question which I have never seen before. You know what is the benefit of that one? I will not be on a set pattern. So I will let you know how you start analyzing the question. So first thing, as you know, as I told you, when you have to find a missing side, the best way is triangle way. And in the triangle, right angle triangle. So I consider as I need the DP. So where, for example, DP is here, DP is in this one. So which one will be a triangle complete with that one? So it is obviously going to be this one. Yes. So I took that. I will collect the data. If it is feasible, good. Otherwise, I will move to something else. I will try to do something else and will try to find. Okay. So I have AB. It's not in that. I have BC, not there. I have CD, it is not there. So nothing is there actually what I need. But I will try to reach to that. Okay. In this case, then there is another right angle triangle because ultimately I have to find this and I need this right angle triangle. So there is another triangle here that can help me somehow to get this one. There is another right angle triangle here. Yes. That can also help me to get at least this side. Yes. Or even this side. So if I will take that, let's say, so in other words, you can separate all the triangles, possible triangles, C, B, A. This one, okay? And this one we know obviously. This is 4, this is 3. This is 4, this is 3. And it can help us to find this, by the way. And if we will have this one, then we can have this one. Yes, it will be useful for us to find this AC. And finding the AC is not a problem at all now because we know this is the hypotenuse. Yes, and this will be the adjacent, this will be the opposite. So how do we find the hypotenuse? The hypotenuse is always mean AC. It will be this square plus this square. 9 plus 16, 25. So 25 square root is 5. It means this one is 5. So I have now this as 5. Yes. Okay. There is another right angle triangle if you see. So take that also because it will be helpful to you obviously to collect some data for you. Okay. Taken this one, yes. If it has been taken, what is this triangle CDA? So this is the right angle triangle. This one is 2. And this one we already found it is 5. Now we need this. So it will help us because you know our target triangle is this where we can get DP. Hmm? So what this will be? Hypotenuse. How do we take the hypotenuse? If I will take now AD, so AD is going to be 5 square plus 2 square because this is hypotenuse. And when you have to find the hypotenuse, we square and add them. 2 square plus 5 square. 4 plus 25 is 29 square root. Let it be 29 square root. Don't write, if you have to use something later, so no need to change it into decimal. Okay? Let it be as it is. It means this one is now square root of 29. It means now at least I have this one. Hmm? Now try to get this or because this is right angle or any angle. Hmm? Or any angle even. So still it can be useful for us. Yes? Right now, if you guys see, the problem is I can get this, but I have 4. There is no additional information about this part at all. Okay. How I can get, there is no, if this is a short triangle, I'm not having this. I'm not having this. Yes, I'm not having if it would be. So then angle also is an option for you. Like if you find this angle, then still it is easy for us to find this. And how we can do that? This triangle can help us to find this angle. This triangle can help us to find this angle, and then this total will be for this triangle. Yes? Yes or not? So I'm gonna consider this same triangle and I will find this angle, which is BAC. Yes? And how I will take that one? Now, in this case, this will be the opposite, this will be adjacent, this is the hypotenuse. It is your choice, whatever you use, because now you have all three sides. You want to use su, you want to use ka, you want to use tua, no problem. Because when you have all three sides, then what is the issue? So I'm gonna use, because this one is the BAC, okay? So I'm gonna use tangent, okay? Tangent of BAC. Remember, the central one is the angle always. Okay, why I'm using BAC? Because A is this also. So just to specify, this one is BAC, this angle. Okay? So it will be tangent, mean opposite over adjacent, 3 over 4. So it means if you want to find BAC, you need to take the tangent to the other sides. So BAC will be equal to tangent inverse of 3 over 4. If you can find, please, tangent inverse of 3 over 4. Hmm? Let's take tangent inverse of 3 over 4. Baba. 3 over 4. Baba. But I'm busy in class. So. Uh, eh, 1 second, hold on. Sorry, guys. Okay, so this is 36.86. Okay, mean you can say it is 36.9. Yes, we got this angle. Now use this triangle and try to find, because we have already AD, this is square root of 29. Okay, so in this triangle, if I will take, it's your choice, whatever you use. If you have all side, usually I use tangent, but up to you. If I take tangent of this CAD, CAD, because again the center one is the angle. What it is? Opposite over adjacent, 2 over 5. So CAD will be equal to tangent inverse 2 over 5. So let's take tangent inverse 2 over 5. 21.8. Okay. So I will have it 21.8. It means this angle is 21.8. So what this total angle will be? Mean the total angle will be PAD. Yes. This is the total angle PAD. What it will be? It will be this angle plus this angle. Like you can say it is 36.9 plus 21.8. 36.9 plus 21.8. So we are going to have 58.7. It is 58.7. It means now this angle is 58.7. I know you will be saying, oh my God, so difficult. But this question is having everything of the right angle triangle. No question will be more difficult than this one. There is nothing technical where just you have to use your brain. I will use this first, this first, this first. Okay. So now you have this triangle. You're having this one. This is the hypotenuse, yes. And you need to find this one, which is the opposite. So it means now this time you will use, obviously, because you have hypotenuse, you want opposite, you will use sine. So you will use, I will use the black to solve this. Value of 3 over 4 and 2 over 5. Iman, come on. When I took this one, in this triangle, this is tangent inverse. Okay. Yes. So many triangles. So what basic rule is in your mind? Basic rule of the triangle, right angle triangle is in your mind. I'm not using any rule other than the given rules. Sukatwa or Pythagoras theorem. So I got it from here. I use the calculator. Tangent inverse of 3 over 4. I got this one. Because I use this to get this angle. Yes. Yes, it is lengthy. I deliberately took this one. So at least everything you will recall from this one. Okay. So obviously, why my target was to get this. So I cannot take it directly because I'm not having the sufficient thing to get directly. So first I use this triangle, mean this one, to get this angle and then this angle. So total angle I got now. When I got the total angle now, so now I will use the sine of 58.7. It will be equal to, what is that one? Opposite over hypotenuse. Opposite is the PD. Over hypotenuse is square root of 29. So take it to the other side and then it will be 29 square root multiply by sine 58.7. It will be PD. Okay. So we got PD from this one. Just calculate it. I know it is one of the most difficult question. Uh, and the rest usually will be easier question. Okay. For example, have a look at that. Quickly, I will do this. Your plan, what it should be. You need to find what? Work out the total length of the four metal bars. The diagram represents a metal frame. This is the metal frame. Okay, it is having these metal bars. All are the metal bars. Okay, one, two, three, and four metal bars. So if you have to work out the total length, you need this, you need this, you need this, you need this. Yes. So first, I will try to find this. I will try to find this AC. So for AC, I will use this bigger triangle. This is A, this is B, this is C. This one is 3, this one is 5. Yes. 90 degree. So Pythagoras theorem. Yes. Pythagoras theorem is very simple. When you have to find AC, mean the hypotenuse, it will be, because this is 90, so this is hypotenuse. Other side square you will add and 25 plus 9, 34 square root. It means this is 34 square root. Yes. You got it, 34 square root. You can call it, if you use the calculator, it may give you the value. Uh, Anyhow, let it be as it is, no problem, because we have to use it later. Now, if you want this one now, so for this one, you have uh, this right angle triangle will be suitable because this is the right angle triangle. That one. This one is 5. This is 90 degree because this is A, this is B, and this is D. But now again, there is a problem in that one. Maybe BC. BC is this one. But in that case, I will utilize, what if I utilize this one? Okay, still it is four metal bars. You know, in this triangle now, what is the problem? If you will write the answer, it will come in the decimal, and then rounding the ultimate final answer effects. So I know I have to use it later, so that's why I don't do simplify. Keep it as it is. Hmm? No, the problem is that I have this only. I need to find this one. Yes. If I will take, I took this triangle, so I found that easily. The problem is this one. If I'm considering this triangle, I'm having 5 and this one. So obviously I will find one of the angle. So then it will be easy for me to do that. But the problem is that again, I'm not having anything. So three things are required. In this triangle, I'm having only two things. In this triangle, if I will take this triangle, obviously if this is 90, it should be 90 because straight line total make 180. So this is D, this is C, this is B. This one is 3 and no other information. Hmm? Maybe some other hidden information is there. Total length give your answer to three significant figures. So what should I do for this one? Hmm? Uh, the only thing in this one is, yes, it will be, but I know. The problem is that you guys are thinking that so 45, 45. It cannot be. There is no such rule that says hmm, the right angle triangle. There is no such rule. Okay. How you can say that it will be 45? Because your instinct is saying that, so no. Hmm? Uh, by the way, I got it. Actually, in this one, later we will study a property similar triangles. Hmm? To find this one, I can do it using the property of the similarity. So right now, for this one, it is enough just to find that. Otherwise, you cannot find this one. Similarity is a concept we will take after this. So we will inshallah discuss it there. So it's okay. That is enough for this one. Now, everyone, please listen carefully.